Hello world. Welcome back. This will be lab number 7. This one is a buildup of the previous labs that we've done, which included finite state machines, the one from the piano lab, which was the one with the chatter and the tones, frequencies. And today, this lab will involve in a similar fashion to the piano lab, where we would have to design a finite state machine. Most of these were skeleton codes where we had to code the case statements. Some people use if-else statements. That should work also. But here I had a few case if-else statements inside my case for when the state is high. And this would activate for every single positive edge trigger. And so we would have idle, load, wait, timer, sample, and increment. This will be provided in the file, so I'm gonna skip straight to the other stuff. And here we have 4 assigned statements. So how this works is this would take a digital input and convert it into an analog input, because we're using this DAC or digital to analog converter. This would be able to help us to turn binary code, Verilog code, into an analog signal, in this case, which is sound that you could hear. Let me scroll up for a bit. So in this chatter file, we have all of these options, right? And each of these has a specific value for the hexadecimal. So that means 00 is uniquely pause. PA1 just means pause for, a short period of time. 2 takes a little bit longer, 3, 4, and 5 finally. And then from here on out, you actually have, I would call these pronunciations, or I forgot what it's called, like IPA, I suppose. So it's just like a way for humans to, I guess, read English, pretty much. So if you were to pronounce a syllable that sounds like oi, then for sure you can go to this hexadecimal value of 05 and select that, and then make up your string of words with these pauses here to mimic real life how do you say, conversation. I think this is a similar, not to say technology, but like a similar use case for people with disability, like maybe people that are mute, like they might need some device like this to be able to help them talk. And yeah, like I said, if you were to make up your string of text or words, sentences, whatever, you can write down these hex values. For example, for my case, I was able to get the string of text E178 to work. So what I had to do was to change this event here in the always block, where my case statement would be the counter, and I would have these kind of like sequence of, or like cases of how do you say this, like basically the FEJ board will be able to string up these and try to pronounce them. So that's why I had to put in these comments here to help me keep track of which hex code is which. And so 3F would be BB, and then 2 would just be like a little, pause or something. Same thing for 0E. R, since my name is Bradley, you just in sequential pattern, BRADLEY. But since this is pronounced as like E, so yeah, I don't know. It's close enough. I could these were like the best hex codes that I could find in the chatter module. So yeah, and then I used a little pause here just so that there's a break between my first name and my last name, HO here, and from here on out, I just used a bunch of pauses. And of course, my default case would be one of the pauses, PA5. So yeah. Of course, we have clocks, data, write, speaker. What else? Oh yeah. We had to go to the IP catalog here to generate the I forgot what it's called. Let me search it up real quick. Okay, yeah, we had to go to the IP catalog to generate I forgot what it's called. Oh, not this. It doesn't pop up anymore. But yeah, from there we had to import a phonemes I forgot what it's called. Phonemes.co, which is a coefficient file. So just phonemes.coe, phonemes.co for coefficient. And in that file, there's like a bunch of radix and some other stuff in there. Anyways, it was all in the instructions. And I can show the simulation real quick before we move on to the demo. So here it is. View, scroll in. It's kind of it's not working. Okay, it doesn't let me drag it out, but speaker is here. My clock is here. And here probably doesn't really say much, but we should go into the demo real quick. So what I have here is just, my FPGA board, and we're gonna use my pair of IEMs as the speaker. So I'm just gonna plug the 3.5 mm headphone jack into this port to act as a speaker, and then yeah, I'm not sure if the phone can pick up the sound from the IEMs, but it tried to pronounce my name and it's close enough. So this project is actually really useful because we're gonna save the code for this project and use this for the final project, which is gonna be the elevator controller. More info on that later when we try to, do lab 8. I haven't taken a look at lab 8 yet, but I think we could also use that for the final project, which had some C and C++ embedded systems within Vitis. So we could use both Vitis and Vivado for lab 8. And in the final project, we're pretty much gonna incorporate everything, the finite state machine, chatter, like stuff from, the piano lab, this lab, what else? Yeah, pretty much everything. Like, it's gonna be pretty cool because in the final project, we're gonna have to actually use this lab to speak like a certain action, like a current floor, or like for example, if you were to press a button and the elevator is going down, then it's gonna say like, oh, the elevator is going down, or if the door is open, or whatever the case may be. So we're looking forward to the final project because I think it's a good way to wrap up everything that we learned for the past semester to integrate them into a single big project that we could put on our resume, and to be able to talk about that during the job interviews, which is like a huge plus for any digital designer. So I'm thankful for this opportunity, and thanks for sticking around.